Have you ever thought about traveling back in time to fix a mistake or forward to see the future? An engaging idea, isn't it? Welcome to the Enigma of Time, a concept that has fascinated us for centuries. The idea of time travel, of being able to journey through the past or future, has been a prevalent theme in our popular culture. From H.G. Wells' The Time Machine to the sci-fi saga Back to the Future, these stories have not only entertained us but also sparked our curiosity about the possibilities of time travel. Time is a concept we are all familiar with. We see its effects every day as we grow older, the seasons change, and civilizations rise and fall. But what exactly is time? Some view it as a constant, linear progression, a ticking clock that never stops. Others see it as a more fluid concept, something that can be bent, shaped, and perhaps even traveled through. This brings us to the idea of time as the fourth dimension. We live in a three-dimensional world where we can move in any direction, up, down, left, right, forward, and backwards. But what if there was another direction we could move in that we can't perceive? Just as a two-dimensional creature can't perceive the third dimension, we humans might be unable to perceive this fourth dimension, the dimension of time. Theoretical physicists suggest that time is intertwined with space, forming a four-dimensional fabric known as space-time. Imagine if we could navigate this space-time, not just in the three spatial dimensions we're accustomed to, but also along the temporal dimension. Would that mean we could travel to any point in time just as easily as we could travel to any point in space? The concept of time travel is undeniably fascinating. It's an idea that challenges our understanding of the universe and our place within it. But is it really possible? Can we truly journey through time as freely as we navigate space? So, if time is indeed a dimension, just like the three spatial dimensions we are familiar with, could we possibly travel through it? To understand time travel, we first need to understand time itself. Time, as we perceive it, is a continuous sequence of events occurring from past to present and into the future, but it's not as simple as that. According to Albert Einstein's theory of relativity, time is not a constant. It's relative and can vary according to the speed at which one is moving and the gravity one is subjected to. Consider two people, one standing on Earth and the other zooming through space in a spacecraft. To the person on Earth, time seems to be moving at a normal pace. But to the person in the spacecraft, moving at near light speeds, time would appear to be moving more slowly. This is known as time dilation, a concept that is a direct result of the theory of relativity. Now let's bring in another concept, space-time. Imagine a seamless fabric that stretches through the universe, representing the three dimensions of space and the one dimension of time. According to theory, the fabric of space-time can be warped and bent by mass and energy. This means that the path an object takes through space-time can be curved, like a marble rolling along a sheet that's been stretched tight and then pinched in the middle. This brings us to wormholes. Think of them as shortcuts through space-time, a tunnel with two ends each in separate points in space-time. Theoretical physicists suggest that if wormholes exist and could be stable enough, they could potentially enable super-fast travel between two distant points in the universe. But here's where it gets even more intriguing. If a wormhole could connect not just two separate locations in space, but also two different points in time, then we might have a method for time travel. One could enter the wormhole at a certain point in time and emerge at a different point in time, effectively travelling into the past or the future. This gives rise to the question, can wormholes be the gateway to time travel? Let's imagine for a moment that time travel is possible. How might it work? The mechanics of time travel have been a subject of fascination for scientists, philosophers, and storytellers alike. The theories run the gamut from scientifically plausible to wildly imaginative. Let's delve into a few of the most popular ones. One popular theory involves faster-than-light travel. According to Einstein's theory of relativity, as an object approaches the speed of light, time for that object slows down. If we could somehow surpass the speed of light, we might be able to travel back in time. Yet, it's important to remember that Einstein's equations also tell us that achieving such a speed would require infinite energy, a hurdle we are far from overcoming. Next up, we have black holes. These celestial bodies with immense gravitational pull are thought to warp the fabric of space-time around them. Some theories suggest that by entering a black hole, one could emerge in a different time or place. But the intense gravitational forces would likely destroy any object daring enough to venture in, making it a less than ideal method for time travel. Then, of course, we have the classic time machine concept, made famous by H.G. Wells. This device would theoretically allow its user to travel backward or forward in time at will. Yet, the science behind such a machine remains purely speculative and far beyond our current technological capabilities. With these theories in mind, we can't ignore the paradoxes associated with time travel. Take the grandfather paradox, for instance. If you were to travel back in time and accidentally cause the death of your grandfather before your parent was born, would you cease to exist? And then there's the bootstrap paradox, where an object or piece of information sent back in time becomes trapped in an infinite cause and effect loop with no discernible origin. These paradoxes make us wonder, is time travel more trouble than it's worth? As intriguing as the idea may be, the complex mechanics and paradoxes associated with time travel reveal a myriad of complications that might make it an impossible, or at the very least, a very troublesome endeavour. So, we've talked about the theory, but is time travel actually possible? Let's dive into the current scientific consensus. Time travel, as we understand it from our favourite science fiction tales, isn't universally accepted in the scientific community. While Albert Einstein's theory of relativity does allow for the possibility of moving forward in time, in fact, we're all doing it right now, just at a fixed rate, the concept of travelling backwards is much more contentious. One of the major barriers to time travel is the sheer amount of energy it would require. Theoretical physicist Kip Thorne once proposed a wormhole-based time machine, but he calculated that it would need an amount of energy equivalent to that of a star. And we're not talking about a small star, but one with a mass several times that of our sun. And then there's the danger of black holes. To manipulate time, we'd need to get up close and personal with these cosmic monsters. You see, black holes have an immense gravitational pull, strong enough to bend time itself, but venture too close to one, and you're more likely to be spaghettified, that's a scientific term by the way, than to embark on a trip through time. But let's not forget about the paradoxes. You've probably heard of the grandfather paradox, where a time traveller goes back and accidentally prevents their own existence. But there's also the bootstrap paradox, where an object or piece of information sent back in time becomes trapped in an infinite cause and effect loop with no discernible origin. These mind-bending scenarios present significant logical challenges to the concept of time travel. Despite these substantial hurdles, the question of time travel is far from settled. Many scientists continue to explore the mysteries of the universe, driven by a sense of curiosity and the desire to push the boundaries of our understanding. The laws of physics, as we know them, do not outright prohibit time travel, and so the quest continues. Despite these challenges, the tantalizing possibility of time travel keeps us exploring and questioning. What does the future hold for time travel? Will we ever be able to journey through time? As we gaze into the horizon of time travel, we find ourselves standing at the edge of a vast frontier, teeming with possibilities and riddled with mysteries. Today, the concept of time travel is largely theoretical, but the future might hold surprises that could turn our understanding of time on its head. The ongoing research in the fields of quantum physics and relativity is pushing the boundaries of what we know about time. Scientists around the world are unearthing fascinating insights that are challenging our current models. Just as the discovery of quantum mechanics revolutionized our understanding of the microscopic world, the future may see breakthroughs that could make time travel a reality. But what would such a reality look like? What are the implications of time travel for society and individuals? The possibilities are as vast as they are intriguing. Time travel could open up new avenues for exploration, for understanding our past and future. It could redefine our perception of life and existence. Imagine being able to witness history firsthand or to peek into the future. What if we could revisit our past, correct our mistakes, or relive our cherished moments? The potential for personal growth and enlightenment is immense. However, time travel also raises complex ethical and philosophical questions. Would altering the past disrupt the present? Could we create paradoxes that defy logic? Would we risk creating a dystopian future by meddling with time? Moreover, just because something is possible doesn't mean it should be done. The power to traverse time could be a double-edged sword, with potential for both great advancement and catastrophic misuse. In a world where time travel is possible, we would need to tread carefully, balancing our thirst for knowledge and exploration with ethical considerations and the responsibility that comes with such power. While time travel remains a topic of speculation and debate, its allure is undeniable. Perhaps one day we might just crack the code.